As a trailblazer in the field of AI, Michael leads Zero G in pioneering super AI technologies that are reshaping industries and driving innovation. So please, ladies and gentlemen, a warm round of applause for Michael as he comes up on stage to give his keynote, Why the Future of AI Depends on Blockchain. A round of applause, Michael! Stage is all yours.
Super excited to be here. Nice to see everybody in the audience. And I'm going to be talking about why the future of AI can't just be about centralized AI, but really depends on blockchains in the future. And this is really a viewpoint that we at ZeroG.ai have created. And what we're, just as a quick introduction, what we're building is essentially the fastest modular AI chain. And we'll get into a little bit into that in a second. But let's talk a little bit about the future promise of AI. Trillions of dollars of value are going to be unlocked. Lots and lots of processes are going to be automated with AI. And then eventually, maybe in 2 generations, some of my professors say we don't have to work for a living anymore. Sounds amazing, doesn't it? But as part of this process, do we want to live in a centralized AI world? This is a key question to ponder on. Because do we trust a handful of companies with societal AI type of use cases? Can you imagine different types of agents running logistics systems, manufacturing systems, or even administrative or governance systems that are controlled by a handful of centralized entities? And so our answer to that is no, we need a decentralized world for governance and specific societal applications. So imagine some scenarios. Let's say you have a beyond human intelligence agent that then basically fakes some centralized database entries, fakes some type of pictures that it's generated, and said like, hey, I've done all this trash collection in this particular area. I've run this kind of entire transportation system, and I've done all of this. But in reality, nothing happened. And so an agent can cheat, especially if you can figure out how to crack into specific centralized systems. And so another use case would be, another horror case would be, let's say you have an evil agent that then is training an evil AI model that then gets directly uploaded into humanoid robots. And so before you know it, you've got a whole Terminator situation that's happening. So how do we think about preventing this? And this is really where on-chain AI comes into the picture. What if, across this entire AI stack, from data collection all the way to agents and DApps, you had a complete provenance trail? What if you had complete immutability? What if you had complete transparency? What if you had complete visibility into what went into these different AI models? Right now, OpenAI is really closed AI because it can't tell you anything about what version of the model is running, where the data came from, who contributed to the data. And so we want to change that. And so on-chain AI really is cheat-free AI and truly open AI. And so what does that look like at each part of the stack? So on the data collection side, what if you could fairly distribute rewards? If you're using your data to train a model, shouldn't you get a benefit from that? On the labeling side, what if you could automatically monitor for malicious training data and different types of model bias? What if you could have censorship-resistant AI data that's stored in a decentralized context? What if there's no single points of control as part of that? What if you had real-time public monitoring for tampering of some of the decisions that these AI models are making on the execution stack? What if you could actually publicly verify different types of compute? Imagine in a smart city, you've got many different types of applications like trash collection or logistics systems, manufacturing systems that are being run, or even ways of moving different goods between the city, and you could exactly prove when something happened and what was done to actually do that. And again, going back to this provenance view, knowing exactly where something came from that was then used in the model, then you know the weights, and then you can also have it in an economic incentive and disincentive type of model, where you can say like, hey, model, you're cheating, so we're going to punish you, or we're not going to give you certain rewards for cheating. And so this is the promise, really, of on-chain AI. So let's talk a little bit about the zero-G journey and what our role in that picture is initially. So this is a very technical field. So as a team, myself, I'm a serial entrepreneur. I've built a unicorn and top YC company before. I'm also a Bridgewater and Bain and Microsoft alumni, and have basically connected with my classmate Thomas at Stanford, who basically called me up late 2022 and said, hey, I've invested in this team called Conflux 5 years ago. Making fun of the best engineers that I've ever backed. They want to start something on global scale. Are you interested in chatting? And so 6 months later of co-founder dating, I came to the same conclusion. I need to start something with these guys. So Ming, 11 years at Microsoft Research, wrote some of the first AI algorithms for Microsoft Bing search engine, and also as a distributed systems and storage expert, and wrote some of the key papers in the space. Fan was originally his intern. He holds 2 Olympic gold medals in informatics. He's a computer science PhD from MIT, and also University of Toronto professor. And so that just highlights that this is a very difficult technical problem that we need to solve. And so we've also attracted a very large team of equally impressive computer science PhDs to solve this. And so we've published many papers on different topics, whether it's blockchain scalability, AI, different types of security measures, and really have an edge at thinking through this problem. Now, this has also garnered a lot of attention from investors. So we recently came out of stealth. We raised a $35 million pre-seed about a couple months ago with a lot of tier 1 investors like HackVC and Bankless and so on in the space. And again, just highlights this is a very important problem that needs addressing. And so we sit right at the middle of the data infrastructure stack in AI. And when we initially found the space in blockchain, and wanting to run fully on-chain AI, we basically saw that in order to store a gigabyte of data on-chain, it costs $60 million. Like, who wants to store any model on-chain? Imagine storing a Llama 3 model if you can even do it on Ethereum. So Web3 is 1,000,000 times too slow and too expensive than Web2, and so we need to fix that. So that's where we saw it. And then the data pipeline also wasn't big enough. We're dealing with 1 to 100 megabytes per second for best-in-class systems. Now, if you want to train a model on-chain, you need tens of gigabytes per second. We're many orders of magnitude off. And so the solution to that is moving from a monolithic Web3 stack to a completely modular stack. And so we're taking one specific area, which is the data availability area, as it's called, where we basically segment data into data publishing and into the decentralized storage. And so this is what it looks like in detail. I won't go through the details because it's quite technical, but the idea is that instead of broadcasting data over an entire network across all of the nodes simultaneously, we erasure code and store the data first, and then only send validity proofs and small commitments throughout the network, very small bits of data. And net, that then fully speeds up this entire network. So instead of 100 megabytes per second, we can generate 50 gigabytes per second per consensus layer, which then becomes the bottleneck. And so over time, we'll also find a way to infinitely scale the data availability capacity for future use cases. So just like you can flip on a switch, have another server in AWS, we can flip on a switch and have another consensus layer to have infinite data capacity. And so from a cost perspective then, we can get to costs that are equivalent or much cheaper than centralized storage systems like AWS. So there's an additional benefit there as well. And so since we started our testnet about a month or so ago, we've garnered a lot of attention. We ran out of testnet tokens very quickly. We get 100,000 hits on our faucet per day, process a lot of data in the Web3 context. That's pretty impressive. Had a lot of wallets as well, and lots of applications for very, very limited validator slots. And so our goal with this is really to build the biggest and largest network of AI meets Web3 partners in the ecosystem. And so we're just getting started on this, but really care about both the breadth as well as the depth of the key partnerships that we have in the space. Also, if you're a builder in the space, we recently announced that we've created an accelerator that's at the intersection of Web3 meets AI in a partnership with One Piece Labs. So if you're interested in building at that intersection, definitely come talk to me, but I'll also give you a QR code in a second. And it wouldn't be a zero-G presentation without having a meme from our community in the presentation. So if you're an Avengers fan or seen a Marvel movie, you probably know Doctor Strange, and he's looked into the future and saw 14 million possibilities. And the key question to him is, and how many of those did you see zero-G? Anybody know the answer? There's only one right answer, which is all of them. And so, super excited again to be here. So please check us out. Our testnet is on the left-hand side. Information about our incubators in the middle. And then you can also follow me on X/Twitter. So thank you very much. It's nice to be here. Michael, thank you very much.